Alrighty, so today is supposed to put all the scale factor stuff together that we should know. Okay, so we learned a while ago that in a dilation, what moves all the points in a picture is the center of dilation, and they either get closer to, excuse me, or farther away from the center of dilation. So they either get closer or farther away from. And the terms we use for closer and farther is closer to the center of dilation is a reduction, and farther we call that an enlargement. Okay, so as long as the scale factor is positive, and you'll see that in just a second. So again, if we start with this pre-image right here, remember that's the original. Pre-image just means original. And the image is the new thing. What did we dilate? Okay, that's the image. The center of dilation is back here. We call that I abbreviated the COD. And what makes the change is again called the scale factor. It either gets scaled up or it gets scaled down. So as I look at this animation in this other tab, the pre-image, the original is what color? So we're looking at this situation here. What is the pre-image? Hopefully, you're noticing one of them does not have the apostrophes, the primes, so that is our pre-image. So the blue is going to be our pre-image, and the red is going to be our image. That's what is the result of the dilation. So again, the blue is the pre-image, and the red. Oh my goodness, red is the image. Okay. So notice in this statement, when the scale factor is larger than 1, bigger than 1, what does the image do? So if I make the scale factor over here, if I put it at 1, notice at 1, it stays the same triangle, which is kind of interesting. And then if I get bigger, what happens? Well, the red triangle becomes larger than the blue. And what happens if I become smaller than 1? Again, that's a reduction. It becomes smaller than the original, than the blue, which is what we need to know. So smaller uh, than 1 is a reduction, bigger than 1 is enlargement. So we want to think about this as bigger. And again, we said that was an enlargement. And when the scale factor is less than 1, we say the image is smaller than the pre-image. And that is called a reduction. And when the scale factor is 1, when it does not change, when the scale factor is 1, the triangle does not change. It is equal. Congruent is probably the word that we want to say there. Congruent. So when the scale factor becomes 0, what happens? So if I make my scale factor 0, I get smaller and smaller to that center of dilation. And when it actually becomes 0, it's scaled down so much that it just turns into a single point. So the question, when the scale factor is 0, the image is a point on the center of dilation. A single point on the center of dilation. And if we don't think about negatives right now, so forget about negatives, excluding negatives, the larger the scale factor, the larger the image will be. Now I want to take you through this for a second. If I show the ratios of the sides and the angle measures, watch what happens. Take a second. Can you see a pattern? Okay. Maybe pause the video. What pattern is happening? First off, no matter how big my scale factor is, all those angles stay the same. Remember, that is what's true about similar triangles, okay? Those angles are always going to be congruent if it's scaled up or down, if they are similar. And whatever the ratio of the sides is going to be my scale factor. So This says r to prime to s prime is over r to s is 1.5, and that's exactly what my scale factor is. So those are the two things we want to see. No matter what the scale factor is, the measure of the angles are always congruent, the same, and then the ratio of the sides is always equal to the scale factor. And remember, ratio, that's just a fancy word for fraction. Okay, so looking at some specific examples, we want to find the scale factor that is used to produce an enlargement. So what does enlargement mean? That means my scale factor is bigger than 1. Okay, so you'll see what I mean in just a second. So what's annoying about these questions is you only have a couple pieces of information, but you do have this similar statement, which is going to be super helpful. So what side goes with ED? Well, ED is the last two letters. So I need the last two letters in the other triangle. Hopefully they gave it to me. It does. VW. Those are the last two letters. Last two letters. Last two letters. So I have some options. Yes, these are proportional, but if it's going to be an enlargement, I need my scale factor to be bigger than 1. So should I do 11 over 88? Or should I do 88 over 11? Well, 88 over 11 gives me 8, and 11 over 88, I am not a human calculator, so let's see what we get there. 11 divided by 88 gives me 1 point, sorry, 0.125. So what's bigger than 1? The 8. So 11 over 88, that is wrong. That would have been a reduction. This is the enlargement. So we went from this triangle, this was the pre-image, and this is the image up there. Okay, so I know that's a little bit sloppy, but if you followed along, hopefully it makes sense. Same thing over here. I've got only ED in this triangle. ED, those are the first two letters there. So I need DU over here. DU is the first two letters over there. First two letters over there. So again, an enlargement. Should I do 143 over 55? Or should I do 55 over 143? Maybe another way to think about this question is, did 43 turn into, sorry, I should say 55. Did 55 turn into 143? Or did 143 turn into 5? Okay, what happened there? Okay, well, if it's an enlargement, it became larger. So the 55 turned into the 143. So that would be this situation up here. Okay, this is my enlargement. And if you would have done this fraction, you would have gotten a decimal less than 1. So 143 divided by 55, that gives me 2.6. So my scale factor is 2.6. That's the ratio of all the sides. And I could even find the missing side over here. FD should just be, if I did 55 times 2.6, 5 times 2.6, I got 143. So if I do the same thing, 50, that other side, times 2.6, I get 130, which is actually going to be that other side. 50 times 2.6 equals 130. Okay, so um, got to be able to kind of say those different things there. And I will do one more. I'll do this last one over here. Notice it says it doesn't say that they're similar. So what do I do? Well, if they're similar, then the sides should all be proportional. So let's say if I set up a proportion with what looks like corresponding sides, I should get that 108, that top side, divided by 24 is equal to um, 90 divided by something. I don't have this side there, so I'm kind of out of luck there. Um, so then I would also want to check, is that equal to 72 divided by 16? This is me checking. I need to check if they are even similar. Again, if they are similar, then those ratios are going to be equivalent. So 108 over 24, that gives me 4.5. And then 72 divided by 16, does that give me 4.5? Yes, it does. Amazing. So, yes, these are similar. Similar because proportional. Because they're proportional. So, now what is the actual scale factor, though? How do I get from, uh, if it's a reduction, how do I turn the big? I need to turn the large, turn the big triangle into the little. How do I do that? Okay. Well, um, I would want to start with 4.5 is one way to see it, or I could try if I did 16 over 72, or I could also do 24 divided by 108. Watch what happens. 16 over 72. I get that decimal smaller than 1, 0. 0.2 repeating. I'm just going to leave it as 0. 0.2. That is my scale factor for reduction. Okay, hopefully that's making some sense. Again, the top part was just me checking. Can I even say is this even a similar situation? What we learned the other day is if this would have been marked parallel, then yes, we could have said those were similar. But that was not given to us, unfortunately. So hopefully you're getting the hang of this, getting into some cool geometry stuff. Last thing I'm going to say is the 4.5 would have been scale factor if enlargement. Okay, that's one thing to keep in mind is the scale factor would have been 4.5 if it was enlargement, but it is not as a reduction. So 0. 0.2 is my scale factor.